This video, I'm going to cover a very light highlight reel of Chapter 7 of the Intermediate Algebra book of rational expressions. So this is in no way a full encompassing review. It's just the main highlighted topics that I wanted to go over. So first, finding the domain of a rational function. So domain is where we're thinking about the x values. And when we graph this, if we were to go ahead and graph this, what we're looking for is any spot on the graph. So if I have a graph like this, where it goes like this, and maybe it goes like this, any spot on the graph where it doesn't exist at an x value. So if I'm at like x equal to -1, I have a corresponding y value. If I'm at x equal to, let's say, +1, I have a corresponding y value. If I'm at x equal to 4, I have a corresponding y value. But the problem here is that there's this gap here. It's called an asymptote, but that's besides the point. But there's this gap here, meaning that it does not exist there. So we're trying to figure out, well, what is that value where this graph doesn't exist on the x-axis? So what we're looking at is the denominator. X to the third plus 9x squared plus 8x. I could factor out an x from the denominator, leaving me with x squared plus 9x plus 8. And then I can factor again. So I have this x that I factored out. Factor again. So x plus 8 times x plus 1. 8 times 1 is 8. 8 plus 1 is 9. So now I have my denominator. And we don't really care what's going on in the numerator. I just want to now set my terms, my factors here, equal to 0. So I'm going to set this equal to 0. That's a common mistake. People factor out that x, but then forget about it. But you want to set that x equal to 0. You want to set x plus 8 equal to 0. You want to set x plus 1 equal to 0. So then that means x cannot equal 0, x cannot equal -8, and x cannot equal -1. So I'm just solving for x on all three of these equations, but the first one already had x by itself. This one, just subtract 1, so I get x equal to -1. So that means that our domain would run from -infinity up to -8. Always going in numerical order, left to right, unioned with -8 to -1, unioned with -1 to 0, and I'm running out of room, unioned with 0 to infinity. So that one has quite a few gaps there. So if we were to draw this out or actually graph this, we would have this happening in a couple spots. We'd have some gaps there. We'd have some potential holes. Like there's a lot of different reasons why we might have a break in the domain. But for right now, all we're worrying about is just what is the domain of this rational function. Like if I had the function, let's say I have f of x equals 1 over x minus 1, just a simple one like that, I would just set x minus 1 equal to 0, add 1, x cannot equal 1. So then that one would just be domain of -infinity up to 1, unioned with 1 to infinity. So we just have that one single spot that we'd have to worry about. So that's finding the domain of a rational function. Now we're going to simplify. So simplifying these expressions, first thing you want to do is just look to factor. Just see if you can factor, then then you could condense it down. On the top, x to the third plus 8x squared. I could take out x squared. So I'm left with x plus 8. On the bottom, I have a trinomial. So I'm looking to factor two numbers that multiply to -48. Add up to 2 is +8, -6, right? X plus 8, x minus 6. So then the simplifying is that we have an x plus 8 on top and bottom. So those are going to simplify, just like if you had the fraction 3 over 3, that would be 1. 3 divided by 3 is 1. Same thing with these rational expressions. X plus 8 and x plus 8 are going to simplify. So we have x squared over x minus 6, and this does not simplify at all. This would stay as x squared minus 6. This x squared and x do not simplify. If it was x squared over x times x minus 6, like this, then you would have a simplification of x squared and x, but I am not able to simplify x squared and this x right here. I just leave it as x squared over x minus 6. So that's simplifying. I think I have another one. Yes, another simplifying. Let's see how this one shakes out. So on the top, I could factor out a 3. I just have a GCF of factoring out a 3. So I'm going to factor out the 3. I get x squared minus 48 divided by 3 is 16. All over. I can factor out a 9. So I'm going to take out 9, x minus 4. Just because you factored the top, factor out a 3, doesn't mean that you're done factoring. You can continue to factor if it's possible. And I have this x squared minus 16. This is a difference of 2 squares. So I'm going to factor the difference of 2 squares now. So I'll have 3 times x minus 4 times x plus 4 all over 9 times x minus 4. Two things happen. I have 3 and 9. 3 goes into 3 once. 3 goes into 9 3 times. So 3 over 9 simplifies down to 1/3. Then I have x minus 4 and x minus 4. So those are going to cancel out. On the top, I just have 1 times x plus 4. So that's just going to be x plus 4. If I was left with, like, let's say a 2, I'd have 2 times x plus 4. Because it's just 2 times that. But I am not left with that. I'm just left with 1 because the 3 over 9 simplified down to 1/3. Then what do we have on bottom? We just have this 3 here. So x plus 4 over 3. So that was simplifying rational expressions. Let's move on to multiplying rational expressions. So x squared minus 9 over x squared minus 2x minus 3 times x plus 1 over x. So we can factor the difference of 2 squares on this top one, x squared minus 9. That's x minus 3 times x plus 3. On the bottom, factor the trinomial. So x minus 3 times x plus 1. Right? Negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. Times x plus 1 over x. I couldn't factor that at all, so I just leave it alone. X minus 3 is x minus 3. So we're looking to simplify anything. Anything in the numerator can simplify with the denominator. Just like if I have these fractions like 2 over 5 times 3 over, let's just say 10, something like that. I could simplify 2 and 10. 2 goes into 2 once, 2 goes into 10 5 times, so I'd simplify that, and then I have nothing else. 3 does not go into 5 in either way, like 3 and 5, 3 and 5. I can't simplify 3 and 5. So I would just do 3 over 25. I would just multiply 5 and 5. Same thing with rational expressions. Simplify the x minus 3's down, and then we look to just multiply, because you're just multiplying everything on top with everything and then multiplying everything on bottom, but we're looking to make those cancellations if possible. So we have the x minus 3's. I don't have, oh, I almost missed this one. X plus 1 and x plus 1. Those are going to simplify. For some reason I was reading that as x minus 1. But that's x plus 1 and x plus 1. Those are going to cancel out. So I'm left with x plus 3 over x. And one more time. You are not doing this. Boom. You are not simplifying those x's. This is x plus 3 over x. Think about if x were to equal 1. If x equals 1, I'm just using an arbitrary number. If x equals 1, this would be 1 plus 3 over 1. Would you ever do that? Would you ever simplify 1's like that when you have a 1 plus 3 over 1? No, you would not. You would do 1 plus 3 over 1. You would add the top. Same exact concept, but with just keeping it as x, whatever x can equal, just x plus 3 over x. And if it helps you, put that in parentheses so you see like, oh, that's just a term of x plus 3 over x. So we get x plus 3 over x for our answer on that one. And just while I'm talking about this, like I don't want to spend a lot of time doing this for every single problem, but just being aware of the domain, just like how we did on that very first example here on this video, being aware of the domain of what x can't equal. Like you'd have to be aware that, well, we have this denominator of x, so x cannot equal 0. We factored the x squared minus 2x minus 3, so that means x cannot equal 3, x cannot equal negative 1. Same thing with these simplifying problems that I did. Just, I'm trying not to make this video go 20 minutes longer than it needs to be, just keeping that in mind, because that comes up in the later rational equations aspect of it. But for right now, it's just simplifying and multiplying and dividing, but it's not something that you should ignore. I'm just trying not to make this video take super long. This is something, if you want to write down the domain restrictions while you're doing this, might be a good idea. Another multiplication problem, finding the products. Y squared plus 8y plus 15 all over y squared minus 12y plus 27 times y squared minus 9y plus 18 over y squared plus 6y plus 9. This is a good problem. We have 4 trinomials. A lot of students get intimidated with a problem like this. Like they look at it, they freak out, they feel like they don't know how to do it. Where if I gave them a problem like this previous one, that's a little bit more manageable because you're not doing so much factoring. But if you look at it as just, if I gave you this problem, like, hey, factor that, I don't think that would be too much of an issue. And then if I said, okay, well, now factor this, I don't think that would be too much of an issue. And you can see that it's just 4 trinomials stacked. That's all it is, just 4 trinomials that we have to factor. So we just look at it as 4 separate problems of factoring. For the first one, top left, we have y squared plus 8y plus 15. That is going to factor to 8 plus 5. I'm sorry, did I say 8? Y plus 5, y plus 3. 5 times 3 is 15, 5 plus 3 is 8. On the bottom, 2 numbers that multiply to 27 add up to negative 12. We want to multiply to a positive, add up to a negative. So that's going to be y minus 9, y minus 3. Top right, y squared minus 9y plus 18. It's going to be, what is that, 6 and 3? Yeah, 6 and 3. Y minus 6, y minus 3. What else? So the y squared plus 6y plus 9, that's going to be y plus 3 squared, or y plus 3 times y plus 3. Not sure what your preference is on that, but that is the factoring there. Hopefully we have some decent simplifications. Let's see, I got a y plus 3 here on top, y plus 3 on bottom. Now keep in mind, this is y plus 3 squared, so I still have a y plus 3. Only one of the y plus 3's cancel out, so I'm left with still a y plus 3. I have a y minus 3, y minus 3, so those are going to simplify. I don't think I have anything else. So we have on top y plus 5 times y minus 6 over, and then we have y minus 9, y plus 3. Yeah, nothing else that could simplify. Just double checking. I feel like something else should maybe simplify down. Yeah, I'm not seeing anything else. Yeah. Okay, well then that one's done. Not as much fun. Usually I want a little bit more simplifications, but this one's not giving us a whole lot. That's okay. Let's move on to division. So division is very similar to multiplication. The difference being that when you have division, you need to change it to multiplication, take the reciprocal. So I'm going to leave 5x to the 4th as is. I'm going to draw this out. Like, I don't want to skip too many steps. So I'm going to just leave this alone. I know you're probably thinking factor that. Like, I know, but let's just change the division to multiplication, then take the reciprocal, and then we can factor where we can factor. So like I was saying, I left the first fraction, changed division to multiplication, took the reciprocal of the second fraction. Now I look to factor. I only have one term to factor, this x squared minus 16. That's the only factoring I could do. So I'll have 5x to the 4th over x minus 4 times x plus 4 times, and then we have x plus 4 squared over x to the 7th. Okay, now we have to make some simplifications. I have an x plus 4 squared right here, so that means we have x plus 4 times x plus 4. We have two x plus 4s. I have a single x plus 4 on the bottom, so that's going to simplify with one of those. I'll just get rid of the exponent there. Yeah, I'm gonna write. So I'm gonna write this as x plus 4 squared. I mean, sorry, x plus 4 times x plus 4, so you could see that cancellation. I don't like just getting rid of the exponent. What else? I have this constant of 5. I don't have any other constants. Like if I had a 10 here, I would do 5 over 10, would simplify down to 1/2. I'm just showing you that as a example there, that 5 would look for some other constant there, but nothing to simplify there. X to the 4th over x to the 7th. Let's do this off to the side. X to the 4th over x to the 7th. That is going to be 1 over x to the 3rd. 7 minus 4 is 3. And then the x to the 3rd would stay where that x to the 7th was. Just like how I showed you here, x to the 4th, x to the 7th would simplify down to 1 over x to 3. So x to the 3rd would stay on bottom. So this will be x to the 3rd now. And then this x to the 4th goes away. And nothing else. So let's write this out. We have 5 times x plus 4. X to the 3rd times x minus 4. And no other simplifications. X plus 4 over x minus 4 are not the same, so that is not going to simplify. Another division one. I wanted to try one that was a little bit more complicated with some more factoring. So I grabbed this one. So we want to change division to multiplication, take the reciprocal. It's 3 over 6x squared minus q times 12x squared minus 2q over 15. Six x squared minus q, I know that looks like a 9. I try to make that not look like a 9, but that is a q. 6x squared minus q does not factor. No, I know you feel like something's got to come out there, but it's just a q, x, 6, nothing. 12x squared minus 2q on the top right, I could factor out a 2 from there. So let's write that out. I'll have 3 over 6x squared minus q times, I'm going to factor out the 2. So I'm left with 6x squared minus q over 15. That means 6x squared minus q, 6x squared minus q, that's going to cancel out. 3 over 15, 3 goes into 3 once, 3 goes into 15 5 times. So after all of that, I'm left with 2 over 5, because I just have this 2 on the top. 2 times 1 is 2. I have this 5 on bottom still. I have nothing else to multiply that with, so I'll just have 2 over 5 as my answer. Cool problem there. I like that one. Next topic, subtracting, adding and subtracting with these rational expressions. So when we are adding and subtracting, we want the same denominator. So that's one thing that we want to make sure we have is the same denominator. So in this case, I have a squared plus 3a minus 54, a squared plus 3a minus 54. So that means that I can just, you could do two things. You could put this all over one denominator. So I could rewrite this as 2a minus 12 all over a squared plus 3a minus 54. You could do that, or you could factor the denominators from the beginning. Like I could write this as 2a over, and then factoring that is going to be 9 and 6. So a plus 9, a minus 6, minus, then same thing, a plus 9, a minus 6, same exact thing. So let's go with that. I'm gonna factor out a 2 from here, because 2 goes into 12, 2 goes into 2. So 2 times a minus 6 over a plus 9 times a minus 6. And when you do that correctly, there's a simplification that can be made. Boom, game over. A minus 6's cancel out. So I'm left with 2 over a plus 9. But the key here with this problem is the denominators have to be the same. If they are not the same, we need to look for an LCD, least common denominator, and then we got to make them the same, and then we got to do some manipulation, got to move some things around. But in this case, we had the same denominator, so it doesn't really matter the order that which you don't have to factor it right now and then put it all over the denominator. If you want to, you can, but it doesn't. There's kind of no rule for when you should do that. It depends on a case-by-case basis there. But 2 over 8 plus 9, nothing else to simplify. Another one with same denominators. So we have over x minus 4. There's no factoring there. The reason I pulled this problem is because of this subtraction. So I'm doing 7x plus 2 minus 3x plus 18. The way that this should be written is, so this is all over x minus 4. So same denominator, so I don't have to worry about that. But the way I should write this is 7x plus 2 minus, in parentheses, 3x plus 18. Because I want to subtract off all of 3x plus 18. That whole entire expression needs to be subtracted off. If I do not put parentheses, I'm going to not subtract off. I'll just have this. I'll have 3x plus 18 like that. I'm not subtracting off the entire 3x plus 18. So that's why I need to put that in parentheses so I know that I have to subtract off that whole entire statement, meaning I have to distribute the negative into here. So I'm doing 7x plus 2 minus 3x minus 18. So I'm taking the opposite sign, if you want to think of it like that, or negative 1 times 3, negative 1 times 18, over x minus 4. Let's see what happens here. I'm going to combine like terms. So 7x minus 3x, those are like terms. So 7 minus 3 is 4x. 2 minus 18. Those are like terms. So 2 minus 18 is negative 16 over x minus 4. That gives us a factor here. We could factor out a 4. And then I think something's going to happen. So let's factor out a 4 from there. So 4 times x minus 4 over x minus 4. So we factor out the 4. Look at this. Boom, bam. The x minus 4's then cancel, leaving us with just 4. It's a really good problem. A lot happens there. There's a big step here with the subtraction. There's a big step here with the factoring. That leads us right to that simplification. I think now I have some different denominators. Yeah, so some different denominators now. So we don't have the same denominator, which I already mentioned before. We have to find an LCD. So before you find an LCD, you got to factor the denominator. So if 7 over x plus 1, can't do anything with that, plus 20 over, I can factor out a 5 from there, so 5 times x plus 1. The LCD then is going to be 5 times x plus 1. So I have this factor of 5, I have this factor of x plus 1, so my LCD is 5 times x plus 1. This first fraction already has the x plus 1, so I don't need to multiply it by x plus 1. I just have to multiply it by 5, because it needs that factor of 5, because the LCD means that all the denominators have to resemble that LCD of 5 times x plus 1. So 5 times 7 is 35 over 5 times x plus 1 plus, and I didn't have to do anything to the second fraction because I already had the 5, it already had the x plus 1. So this is 20 over 5 times x plus 1. Same denominators. Sorry, yeah, same denominators, so add across the top, 35 plus 20, thought I misspoke. That's 55 over 5 times x plus 1. 55 over 5 is 11. Simplifying 55 and 5. So 5 goes in 5 once, 5 goes in 55 11 times. So it's 11 over x plus 1. Now I know you might be thinking there's a little bit of a shorter route. And this, some people catch this, some people don't. When I factor out this 5 from here, look at this. 5 and 20. I could simplify 5 and 20 right there. Make that 4. So that would be 7 over x plus 1 plus 4 over x plus 1. The denominators are now the same because of that simplification. 7 plus 4 is 11. 11 over x plus 1, same exact answer. The only reason I blow right past that detail is because people won't catch that most of the time. Like, you'll just get into this rhythm of, okay, I factor out the 5, find the LCD, and that might not always happen. Like, if this was a 21 over 5, I couldn't do that. So I'd still need to understand the concept of finding the LCD and manipulating the fractions and working through it that way. So I just like to throw that one in there just so you could see two different ways to approach that type of problem. Let's look at another one, different denominators. The denominators are already factored, so I don't have to do anything there. I just have to find the LCD of x minus 7 times x minus 3. So we have this factor of x minus 7, factor of x minus 3. Okay, so the first fraction needs the x minus 3. Second fraction needs the x minus 7. So on the first fraction, when I multiply by that x minus 3, I have to do 2x times x minus 3. On the second fraction, I have to do x times x minus 7. But notice on the second fraction, this is minus. Same exact topic I was discussing a minute ago. When you're subtracting off an entire fraction and you have this binomial, if you want to think of it like that, like, then you have to make sure you're using distributive property of that negative. So you can distribute a negative x into here if you want, or you could distribute the x and then distribute the negative. It doesn't matter what you do, just you got to make sure you're accounting for that being negative x, or subtracting off that entire statement there. So 2x times x, 2x times negative 3, 2x times x is 2x squared. 2x times 3 is negative 6x. And I'm just going to factor out the negative here. So negative x times x is negative x squared. Negative x times negative 7 is positive 7x over the LCD of x minus 3, x minus 7. Where do we go from here? 2x squared minus 1x squared is 1x squared. Negative 6x plus 7x. Negative 6 plus 7 is 1x over x minus 3, x minus 7. I could factor out an x squared and x. I could take out x. That's going to be x plus 1 over x minus 3, x minus 7. That doesn't really help us out, but it's always good to just factor and try to simplify as far as possible. But again, that doesn't do anything for us. Like, I don't have an x plus 1 over an x plus 1. So I would just leave it as that. And what's tricky though? A little tricky with finding the LCD, but that's the key here. LCD is just making those two denominators the same. So what do they both need? This one needs the x minus 7. This one needs the x minus 3. And then you go from there. And this multiplication step, a little tricky too, especially with that minus sign there. Really easy to blow by that detail. I think that's going to lead us into equations. Yeah, so rational equations now. This was a tough section. Rational equations, we have 4r minus 4. Let's factor all the denominators. So this one is going to factor to r plus 5 and r minus 3. That was a bad r. Plus 3 over r plus 5 equals 3 over r minus 3. Okay. So now that we have that factored, we can identify the least common denominator to be r plus 5, r minus 3. Because this has the r plus 5, just 1, r minus 3. So that would be our LCD, just making sure we're accounting for all of the factors in the denominators. Now that I got that, I'm going to multiply everything by the LCD of r plus 5, r minus 3. Let's multiply this out. R plus 5 times r minus 3 times all of that. R plus 5 times r minus 3 times all of that. And then on this side, we're doing the same thing on the right side. So when I multiply the first one, r plus 5, r minus 3 times this first fraction here, r 4r minus 4 over this, the LCD cancels out with the denominator. That term that I multiply with is going to cancel that out completely. So that means I'm left with 4r minus 4. plus, and then I still have to multiply this to here. So this is going to be r plus 5 times r minus 3 times 3 over r plus 5. And the whole reason why I multiply by an LCD is to have the denominator simplify out, cancel out, or simplify. So that means now I'm left with 3 times r minus 3 equals, and then on the right side, the r minus 3's cancel out, leaving us with 3 times r plus 5. The whole goal for that step is to get rid of the denominators. And if it doesn't happen, then you did something wrong. You forgot a term somewhere, but the denominators should completely cancel out, and you should not be left with any denominators. Now we have to distribute. We're just solving an equation from here. So 4r minus 4 plus 3r minus 9 equals 3r plus 15. I'm going to go through the solving a little quick. So I have 4r plus 3r, negative 4 minus 9, 4r plus 3r is 7r. Negative 4 minus 9 is negative 13 equals 3r plus 15. Minus 3r, add 13. I'm going to go over here. So 7r minus 3r is 4r. I added 13 over. 15 plus 13 is 28. Divide by 4, r is equal to 7. Double check something here. Double check your denominators. So when we factored everything, we came up with r cannot equal negative 5 and r cannot equal positive 3. My answer is r is equal to 7. That is completely fine. Nothing wrong with r equal to 7. So that is a completely valid answer. No issues whatsoever. Good problem there. Tough problem. Good problem. 13. I think I just have a couple left. I think I have this one. Let's see. Ooh, distance question, and then a complex fraction. Yes, a couple more. Hopefully this is giving you a nice little review. It says the quotient of a number in 4 minus 2 equals 5/4. Find the number. So the quotient of a number in 4 minus 2. So x divided by 4 minus 2 equals 5/4. Find the number. Sometimes it's good to reread these a couple times because what they might be looking for is this. Like they might be looking for the quotient of a number like minus 4 like that. Or sorry, not in this specific case, but they might say like the quotient of a difference of a number in 4, something like that. But in this case, it's saying the quotient of a number and 4, so division of a number in 4, and minus 2 equals 5/4. So that's how I'm interpreting it. I think then that means we have to find an LCD of 4. We're going to multiply both sides by 4. This is a little bit easier than that last one. That's 4's are going to cancel with that first one. So x minus 8 equals 4's cancel equal 5 plus 8 x equals 13. For some reason, when I pulled this problem, I must have read it differently. I thought I read it as, I don't know if I pulled a different problem. Quotient of a number in 4. Yeah, I mean, this is the problem, but I could have sworn I pulled a different problem. That's all right. Distance question. A car travels 280 miles in the same time that a motorcycle travels 240 miles. If the car's speed is 10 miles per hour more than the motorcycle's, find the speed of the car and the speed of the motorcycle. So this is a distance equals rate times time problem. So let's gather all the information. We have a car and a motorcycle. The car travels 280 miles in the same time that a motorcycle travels 240 miles. if the car speed is 10 miles per hour more than the motorcycles, find the speed of the car and the speed of the motorcycle. So the car went 280 miles, so let's fill in that gap of 280. Motorcycle went 240. The car is going 10 miles per hour faster than the motorcycle. So if the motorcycle is going 20, the car is going 30. The motorcycle is going 50, the car is going 60. So how could I illustrate that as an expression? If the motorcycle is going X, the car is going X plus 10. So I'm missing this component of time. But if I go back to my formula, distance equals rate times time, I can solve for time. I can divide by r, so time is equal to distance over rate. So I could rewrite this as 280 over x plus 10 and 240 over x. Then, how do I set up an equation, or how do I set this up and actually solve for the variable? It says that a car travels 280 miles in the same time that a motorcycle travels 240 miles. So they're saying that it's taking the same amount of time. That means I'm going to set them equal to one another. 280 over x plus 10 is equal to 240 over x. And then it's a proportion, so we cross multiply here. 280x equals 240 times x plus 10. Go through the solving kind of quick. 280x equals 240 times x is 240x plus 240 times 10. I don't want to make any mistakes here. 2400. Subtract 240. 280 minus 240 is 40x equals 2400. Divide by 40, x equals 60. So x equals 60, so that means the motorcycle is going 60 and the car is going 70. So the car is going 70 miles per hour. And the motorcycle is going at 60 miles per hour. There it is. Last one, complex fractions. So complex fractions look way more difficult than really I think they are. I think if you can navigate your way through a rational equation, then you could be able to navigate your way through a complex fraction. So the main idea here is you're looking for an LCD, which I have the denominator of xy, I have yx, so the LCD would just be xy, not x squared or y squared or anything like that. If this was, in fact, like x squared here, or y to the third, then our LCD would be x squared, y to the third. It'd have to account for the highest degree on those exponents, but in this case, it's just x to the first, y to the first for top and bottom. So I'm multiplying top and bottom by the LCD of xy. So on top, the xy's cancel out, leaving us with x squared minus y squared. On the bottom, xy times 1 over y, xy times 1 over x. Y's cancel, so we are left with x. Just happened. What is it? Minus xy times, so this is still xy. I know I canceled out the y with here, but I still have to multiply the xy times this. So let me just rewrite that. Whoops. So xy times 1 over y, y's cancel, leaving us with x. Then I have xy times 1 over x. X is canceled this time, so we're left with y. Don't assume that we're done. Because if this is kind of sneaky, on the top, look at that. X squared minus y squared. That is a difference of 2 squares. So that is x minus y times x plus y. Difference of 2 squares. Over x minus y. X minus y over x minus y. Those are going to cancel out, leaving us with just the x plus y. So pretty sneaky there. Pretty sneaky with that factoring, that difference of 2 squares. So make sure you factor that out, because then there's that simplification of x minus y. So that was all of chapter 7. I hope this helped.